Today we're analyzing Crappy's cold table on steroids crap strategy. What I do on this channel is program 100,000 bots to play a strategy over 10 shooters. I usually end up with about 8.5 million rolls, and I track all kinds of statistics that we can examine after the run. The strategy overall is pretty simple. It's just a pass line bet for 1 unit, 2 unit don't come bets, and 2 come bets for 1 unit each. Crappy also limits his outlay per shooter to 7 chips, which is actually $175 per shooter since we're at the $25 table. First, we'll look at a replay of one of the simulated sessions, and then we'll go into the actual statistics and see how the numbers work out. We start off with a $25 pass line bet. And the shooter sets the point of 8, so now it's time to add 2 units on the don't come. That's $50 for us today. The don't come is going to move behind the 6, and it's time to make our first come bet. The come bet moves to the 9, and we make our second come bet. And that second come bet is going to move to a 5. So now we're all set up and we're just going to wait to hit. The 10 does not affect us. And the shooter hits the point of 8. So we're going to win $25 on the pass line. And then we'll make another pass line bet. At this point, all our bets are working. And there's our 7. So we lose 2 come bets and we win the don't come and the pass line. So I think this is enough to demonstrate how the strategy works. The only thing we didn't see here is that if we exhaust the $125 per shooter, then we're not going to make any more bets, but that didn't happen in this scenario. So let's go ahead and look at the data. Let's start off today by looking at the bankroll that each of these bots needed to be able to play this strategy. And the way that I do that is looking at this metric I call out-of-pocket outlay. Essentially what that does is it tracks whether each bet is made from winnings or if it's from new money that's really coming out of a bot's pocket, new money that's being introduced to the table. And that way we can figure out what is actually needed to play this strategy. The minimum out-of-pocket per shooter is $25. The maximum outlay is $175, but the majority of the time it's going to come out to less than that. The median is just $100 and the average is just $110. The middle 50% is between $75 and $125, and the middle 90% is just a little bit wider than that. Now, it is kind of interesting that some of the bots got away with just that first $25 investment, but you can see here that that's happening less than 5% of the time. I think it actually gets a little more interesting on the full session level. Here the bots are playing for 10 consecutive shooters, and their wins on an earlier shooter will carry over to subsequent shooters. Again, the minimum is $25. That bot got lucky right away and stayed in profit for their entire session. But the maximum is only $10.50. The theoretical maximum would cost $175 10 times in a row, but that didn't actually happen in these 100,000 sessions. The average is just $280, and 95% of the bots never outlaid more than $575. If you were playing this strategy, you would need to decide what level of risk that you would want to take, but these results tell me that $1,750 or even $1,000 is probably overkill for a 10-shooter session. Here's the average hourly outlay at a couple different table speeds. Now let's get to the good stuff. How often and how much did these bots actually win? We'll start by going back to a per shooter level. 45% won money, and on average that win was $70. The bots lost at nearly the same rate, with losers losing about $5 more than winners won when they won. And we have a fairly significant number of pushes that broke even. And that's the nature of the hedging and the overall play of this strategy. The most that any bot lost was $175. and the most won was $650 for a single shooter. The distribution is centered right around zero. 90% of the bots ended between plus and minus $125. Next, we'll view it from the 10 shooter session perspective. For these longer sessions, just over 43% won, and on average, they won $207. 53% lost money, and on average, that loss was $221. And we still have some pushes here. Overall, 47% either won money or at least broke even. The most any bot lost over a full session was $1,050, and of course, we saw that number in the outlay section as well. And the most won was $1,150. Here we have a nice bell curve that's just shifted slightly towards a $25 loss. Of course, that's the effect of the house edge. You can see here the middle 50% and the middle 90% of outcomes. Before we get to the house edge stats, let me show you these two things. First, this chart compares the length of a session to the amount won. The x-axis is the number of rolls, and the y-axis is the amount that was won or lost. Full table on steroids has kind of a round shape. For light side strategies, we usually see a kind of upward trend because the bots make a lot of money on longer rolls, but on this one, not so much. In fact, if you look over here, there's actually a pretty long session that lost a little bit of money. I think that that's partly due to the hedging, and it's partly due to the limit of 7 units per shooter, so it's not like continually replacing over those longer sessions. I know that Crappy has some versions of this that press their wins, so definitely let me know in the comments if you would like me to make a video on that and how exactly you think we should press the wins. The second thing I wanted to show you before we get into the house edge is new. It's actually an analysis of the comp value that you might earn with this strategy. I laid out a couple table speeds and durations of play. For example, if you played at a half full table for 2 hours, the casino would expect you to lose $51.70. That's called the average daily theoretical, and it's a function of the casino's advantage and the amount wagered. The casino is going to apply some kind of comp rate. I used 25%, so the value of that play might be $12.93. Of course, this is going to be different for casinos and different for different speeds and all of that, but this kind of gives you an estimate of what might be earned with a particular strategy. I run way more simulations and generate more metrics than I have time to make videos for, and I've been really looking for a way to share those with all of you. So I am building a website. It's called DiceData ThinkTank, and it's where I'm going to post all of these strategies and more. So please sign up to the waitlist, and this really helps me gauge interest before I invest too much time into the project. Next, let's look at the metrics from the casino's point of view. The total drop was 28 million with $194 million bet. The players won 94 million and lost $97 million. The difference between that is the house take, and that leaves us an overall edge of 1.417%. That makes perfect sense. Remember, we're making pass line, come bets, and don't come bets, all of which have very nice low house edges as compared to other bets on the table. Now, that's all I have for you today. Thanks for watching and good luck out there.